This is the first of a two-part series on virtualization, part of Cloud Architect. Planning to pursue a Cloud Architect certification or a career in said or real related field? This and several videos to follow are tailored to provide you with technical information to help on your journey. We try to make our videos short. We provide guidance you will need to do as prerequisite for part 2, applying what you have learned here. A light agenda, but crucial to getting you ready for part 2 and the basics to understanding cloud-based virtualization. We recommend you understand the concept provided in this video before you move on to part 2. Also, key topics relative to Cloud Architect certification will be discussed, assuming you will broaden your knowledge through additional readings. The scope of this video will be on theory of cloud computing and virtualization in the cloud. The scope of phase 2 video will provide the steps that will guide you on the manual walkthrough of a hands-on cloud virtualization project based on this use case. A scalable web application infrastructure for a small to medium-sized business or startup, in which we will demonstrate the power of using cloud services to manage, scale, and secure applications without the overhead of managing physical servers. Understanding the theory and successfully performing the manual steps to your environment with the AWS account you establish will more than prepare you for part 2, in which infrastructure as a code, Terraform, will be used to programmatically implement what was done manually. Here are a few aspects of Cloud Architect in terms of security, resilience, performance, and cost optimization. Cloud architecting is categorized into 4 domains. Domain 1, design secure architecture, in which you, for example, implement strong identity and access management, IAM, by ensuring the right people have access to the right resources using roles, policies, and multi-factor authentication. Leverage encryption and network security to effectively protect data both at rest and in transit using encryption, secure communication channels with firewalls and VPN. Domain 2, design resilient architecture. Example, incorporate redundancy and fault tolerance by using multiple availability zones, load balancing, and auto scaling to ensure systems stay operational despite failures. Another, design for disaster recovery by implementing backup and replication strategies to quickly recover from unexpected outages and data loss. Domain 3, design high performance architecture. Example, optimize resource provisioning by choosing appropriate instance types, storage, and networks that align with application workload needs for efficient performance. Another, use caching and content delivery networks, CDNs, to reduce latency and improve load times by caching frequently accessed data and utilizing CDN for faster global delivery. Last but not least, Domain 4, design cost optimized architecture. Many projects fail because this is ignored. Monitor right size cloud resources by continuously assess resources utilization and scale appropriately to avoid over provisioning or underutilization. Another, leverage reserve instances and spot instances by taking advantage of price models like reserved and spot instances to lower long term cloud service costs. Want to become a cloud architect? Skills required at a glance. Programming language. It's good to know multiple programming language. Finances. Be in tune with the finance. Avoid depleting your client's budget. Big data architect and design. Cloud-based systems for enterprise large companies are normally for processing big data. Governance, networking, security, visualization, operating system, Red Hat, Windows, etc. Orchestration, Docker container. While we'll not be covering that later on, we'll cover that and show how that Kubernetes is used to orchestrate them. Application architecture. Design your application very well to be efficient. Responsibilities included, but not limited to those that you see to the right, to the left. Build cloud environment using the cloud provider's tools or infrastructure as a code, such as Terraform, Ansible, Packer, etc. We will provide more insight into this concept during the use case discussion. Monitor cloud compute strategy. Example, using CloudWatch or real-time monitoring. Track metrics such as CPU utilization, memory usage, and disk I/O to ensure the performance and health of the EC2 instances. Set up auto scaling with CloudWatch alarms. Automatically scale compute resources based on performance metrics and use alarms to trigger scaling actions when thresholds are breached. These strategies help ensure that cloud compute resources are efficiently monitored and adjusted based on real-time usage and performance needs. Design application. That will then be hosted in the cloud. We will be doing one based upon the simple use case. Plan for cloud adoption by assess current IT infrastructure and business needs. Conduct a thorough assessment of on-premises workloads, identify cloud adoption drivers, and define clear goals for migration, such as cost savings or scalability. Establish a cloud migration strategy and roadmap. Develop a phased approach for migrating workloads to AWS, considering factors like security, compliance, and application dependencies to minimize disruption and ensure smooth transition. Let's take a high look at virtualization. There are many flavors of VM software. However, the cloud provider handles this by virtualizing hardware so that shared resources are supported. You will not need to know too much details on this, but an interesting topic to understand. So I urge you to go out and do some reading, get some more information on that to understand it. Guest OS, example, Red Hat. You definitely need to be able to move around Red Hat, Windows running in VM, not on the hardware itself, and apps themselves. So you're more responsible for the apps and the guest OS. For certification and also working as a cloud architect, you will be required to know these services, the services distributed across the 6 core service categories. This table on the left is provided to you so you can acquire the knowledge required for the certification and working as a CA. Throughout the walkthrough, we'll cover a few. For example, setting up an EC2, VPC, S3, RDS. We'll go through a few of those, IAM. However, if you're going to go for a certification or for a position as a cloud architect, you really need to understand each of these, when to use them, the pros and cons, the limitation, etc. Lambda is a very key one. You need to understand that one. So let's dive a little bit deeper now into the architecture itself. For certification, understanding for certification and also working as a CA, you will be required to know these services distributed across the six. That's the previous slide as we discussed. Understanding this and the next few slides are crucial, so we will spend a little more time discussing them. VPCs, this outer boundary, similar to traditional network but in the cloud, comprise of multiple availability zones. Availability zones, we have two here, zone A, zone B as demonstration, is a geographically isolated data center within a cloud computing region designed to have its own independent power, cooling, and network infrastructure, allowing for high availability by distributing services across multiple availability zones, so that if one zone experiences an outage, the others can still operate and provide service. Essentially, it's a separate location within a region that minimizes the impact of localized disruptions like power failures or natural disaster by ensuring redundancy across multiple zones. Availability zones are always located within a specific geographic region, meaning they are close enough to have low latency connections, but far enough to avoid being affected by the same local event. Subnets, these little guys here, or subnetwork, is a local division of a larger IP network, essentially creating smaller, more manageable network segments within a single network, allowing for better traffic management and organization of services within the network. Devices on the same subnet can directly communicate with each other without needing to go through a router to reach other subnets. NAT gateways, right, as you see these within the public subnet. Because a private subnet contains only resources with private IP addresses, these devices have no way to reach the internet by themselves, so they need a little help. This is where NAT gateway comes in. A NAT, network access translation gateway, is what facilitates the internet access for resources sitting in a private subnet in a VPC. The NAT gateway is placed in a public subnet within the VPC and given a public IP address. This allows, given a public IP address. This allows the NAT gateway to connect through the internet gateway to the public internet and translate the private addresses of the resources to private subnets into a public address that can be used to connect to the outside internet. The NAT gateway facilitates that connection and remembers where to route traffic back to the source private IP address within the VPC. In order to allow this type of connectivity, the route table associated with each subnet must have a route defined with the destination CDR as 00